Hello everyone, welcome to this today's video. So in this today's video, we'll be solving the problem New Year resolution. This is a medium level problem and it's the problem of the day of on Geeks for Geeks today. So there's a lot of information given here. We'll directly jump to the examples and see what is the actual question is, what the actual question is asking for, and the expected time complexity is O of n into sum of coins and oxidation spaces O of n into sum of coins. Okay, and these are some of the constants that are given. So let us directly jump into the examples and we'll briefly understand. Fine. So there's a person named Geek. Okay, there's a person named Geek, and he is also solving the problem of the day just like us. Like each and every day, he'll be trying to solve a particular problem of the day. He will try. That doesn't mean he'll definitely solve it or not even attempt it. We don't know. Okay, so that's it. Like every day there'll be problem of the day. But in the cases in our general real life scenario, we'll be awarded one coin if we solve that particular problem of the day on any day, right? So on Wednesday, if there is a problem of the day and if we solve it, we get one coin. On Thursday also, if we solve, we get one coin. But for Geeks World, there is like on 8th day it will differ. So on 0th day there can be 5 coins, on first day there can be 10 coins. We never know. Okay, so that is what it is given, and this is the target. Okay, this is the number of days that Geek can be active to solve. Okay, this is the number of days that Geek can be active to solve, and these are the number of coins that will be awarded if Geek solves the problem of the day on that particular day. Like if he solves 0th day, he'll be getting 5, first day 8, second day 9, third day 10, like that it goes on. And on 8th day if we solve, he'll be getting 5 coins. Now Geek's target is to use these coins to redeem Geeks for Geeks merchandise. Okay, so what are the conditions for redeeming merchandise? If the sum, okay, if the sum is exactly divisible by 20, what do you mean by sum? Sum is the total number of sum of the all the coins that you have got, sum of all the amount. So it is exactly divisible by 20 or divisible by 24 or equals to 24. Okay, and also in the question it has been given that your sum, okay, sum will not exceed, okay, the sum of the coins will not exceed 2024. It will always be less than or equal to 2024. So that is one thing given. So sum will go up to max up to 2024. So in that case, if it is equal to 2024, then also we can return to. So how many ways he can win? 3 ways. Either he can have this or this or this. Okay, so now what is the task is, in out of n equal to 8, you need to choose such a combination so that the sum of that particular coins will be divisible by 20 or 24 or equal to 2024. Let us come to this example. Why is this output 1? In the explanation you can see that Geek can fulfill the criteria in many ways. One way is to solve POTD on 4th and 5th day. So if we solve on 4th and 5th day, what is the sum is going to get? 10 plus 14 equal to 24. Is this divisible by 24? Yes, it is. So he can win the merchandise. Or what is another way? He can solve on 1st, 4th and 8th. So 1st, 4th and 8th is enough. This one, this one, this one, and 8th one. So what is that sum then? 15 plus 5 plus 10 plus 5. Okay, that comes out to be 20. And is it divisible by 20? Yes, it is. So even Geek can win that way. What is the third way? If all the sum equal to 2024. But is that going to be possible here? No, that is not possible. Sum is not equal to 2024, right? The elements are very quite small. So that condition need not be taken into picture. So only either he can get 24 or 20. So in both of these ways he can win. So that's the reason output is true, right? So that is the thing that you need to check. If you are able to get a sum, perfect sum of that is divisible by 20 or divisible by 24 or equal to 2024, that's the only task that has been given to you. So I hope you people have understood. So if you are able to find a combination, return true, else return false. That's it. Now what is the brute force approach to solve this question? Very easiest approach. If let us assume, do not consider this in a coding point of view, let us assume I've given this as a general task to you. How do you do it? You'll be taking every coin. Let us start with this particular coin. You'll be taking two things. Either you consider it or do not consider it. Okay, you'll be considering it. Let us assume you're considering it. So your sum would be equal to 5. Let us assume you are not considering it. So then your sum will be 0. And now you'll be coming to this particular 8. Again, now in this two conditions are there. You can include 8, do not include it. If you include 8, your sum will be equal to 13. If you do not include it, your sum will be equal to 5 only. And in this case, if you include 8, you'll be getting sum to be 8. If you do not include, your sum will be equal to 0. So we have got 4 possibilities, right? So here you have 2 possibilities. Here you have 2 possibilities. So 2 into 2, total 4. So till now only this point we have considered. Okay. So but till that considering, we'll be getting 4 possibilities. That is what we have got: 13, 5, 8, 0. And now again, if you come to this, again 2 possibilities are there. Again, you will add that into all the 4. So that comes up to 8 possibilities in total. So in every possibility, you will be checking whether the particular last sum you're getting that to be divisible by 20 or 24 or equal to 2024. You'll be checking these three conditions. If any one satisfies, then you'll update your answer to be true, and finally you'll return that answer. I hope you people have understood. This is a brute force approach. So the same thing I've coded here. So int answer equal to 0 tells the bool, because we have int here, so int answer equal to 0, true or false, 0 or 1. Okay, and calculate is the function that I have written. This 0 denotes the sum of the coins, and once you come to the function, this is the base case, let us leave that. So first condition is consider. Okay, consider the I minus 1th coin. So I'm coming from last. Okay, so like this is the coins array, so I'm coming from this particular point, I'm coming from this particular. If I consider it, then I'll be adding it. If I do not consider it, I'll not be adding it. So I'll then move on to the next previous thing. So how do I move out? So it's basically this, if you can carefully observe, so I'm updating my n minus 1 at n to be at each and every iteration. Okay, instead of using a for loop or keeping an index I, I'm using n minus, I'm updating my n, because once I've used this particular coin, what will be my previous one? N minus 1, right? This would be my n minus 1. So that number of coins that are left is n minus 1 coins are there. So that's the reason I'm updating this. So if you consider, you'll be adding. If you do not consider, you will not be adding anything. So at each and every thing, you're considering a lot of every possibility, and finally when you come to n equal to 0, that means you have exhausted all the coins. Okay, now you'll be checking if your sum is not equal to 0. Okay, sum should not be equal to 0, there must be sum, and sum must be divisible by 20, or sum must be divisible by 24, or sum must be divisible by 2024, that means equal to 2024. So if any of these cases is fine, then you'll be putting your answer to be 1 and finally returning it. Okay, it's a void, so you need not return anything, and your answer would be 1 if in case you found anything. Answer is equal to actually storing the bool, true or false, right? And finally you will be returning that answer. If in case you're not entering this if loop, okay, then your answer will never be updated, it will always be 0. So finally you will be returning false. I hope people have understood what are we trying to do, right? So we have actually used the recursion. So what is the time complexity here? 2 power n. Okay, O of 2 power n. Why? For each and every coin there is a two choices, considered, not considered, and how many coins are there? N. So 2 power n it goes, and n is going up to 365 if I'm not wrong in the constants. If you inject 366, 2 part 366 is very tough. You cannot put it, you cannot use that particular solution, that's not feasible. So you will try to memorize it. Okay, if you try to memorize it, what are the things that are changing? If you I'll just consider, I'll just erase this all part. Okay, so if you try to memorize, what are the things that are changing at every instance? Sum is changing and your number of coins is changing. So you can use these two parameters and try to memorize it. Okay, and do that as a follow-up. I'm leaving that as a task to you people. So memorize this stuff. Memorizing is very easy, just the same thing that you'll be returning, just you'll be using another 2D vector or a map to store the results. But this also will not work because the constants are pretty good, pretty high. So coins of 2024, sum of goes to 2024. So even memorization does not work for some of the cases. So that's the reason we need to come up with some good approach. Okay, why am I doing this? Fine. So what is that approach as? What is another DP or method that we can come up with is see, like here as we can see, for each and every condition, okay, for each and everything we are going again and again to the previous work. Okay, so this is where recursion is actually making us work for so many number of times even on the same particular combination. Okay, so let us assume you are working out to make a sum of 10 using 2 coins. So you might be calling this condition, this particular combination again and again and again, isn't it? You might be calling a recursion for this particular target of 10 using 2 coins again and again and again. We never know. So there's a big calculation, repetitive calculation going on. That's the reason you're storing them in a 2D vector or a map. You're doing something and you're storing that result, and you'll be using that particular result whenever it is necessary. But instead of even doing that, okay, so directly we can come to a conclusion. So how are we going to do it? So the DP state, we can define a DP state. How can we define a DP state? So DP state tells that, so if you have I coins, okay, if you have I coins, so store the result. So what could be the result? True or false. Okay, true or false. For true or false, accordingly if you can form a sum of j using those icons, so what do I mean by that? So if you have I number of coins, okay, I coins, and you have a j sum to be done, okay, j sum to be formed, so you can store the DP of I of j to be true or false if you can use this particular I number of coins to make a sum of j. Use in the sense, it's not like you'll definitely be taking each and every coin into the consideration. I mentions the index, okay, I mentioned the index. So index in the sense, till that index, if you can try to form use any coins till that index to make a sum of j. That is what it mentioned. So let us assume I'm talking about this particular index idx. Dp of this idx, what is this? 0 1 2 3 4. Okay, dp of 4 and sum, I'll take a sum to be 14, is actually true. Why is it true? Because till fourth index I can use the elements till fourth index to make a sum of 14. How? 9 plus 5, right? 9 plus 5 equal to 14. So I'll be putting it as true. I hope I'm making sense. So dp of ij denotes that I can use some number of coins till that ith index to make a sum of j. Okay, that is the thing. If it is yes, then you store true. If it is not, store false, right? That is what we will do. Now how can we come to the conclusion? Starting with the base case. Okay, starting with the base case. I'll just erase this. Starting with the base case. Base case in the sense common sense. Okay, whenever you come to the base case, that means you use your common sense. What is that common sense? With zero number of coins, can you make any sum? Can you make any sum? No, it is not. False. Okay, so with zero number of coins you can never make any sum, so it's false. With I number of coins, okay, where I can go up to 1 from n, 1 to n, that is given in the question, can you make zero sum? Can you make zero sum? Yes, it is true, because you can be like, I'll not be considering any sum, okay, I'll not be considering any coin. So in that case zero sum is possible. Okay, so I denotes the index, remember that. So from index I equal to 1 to n, okay, I equal to 1 to n or 0 to n even, you can put zero sum to be true, because you need not consider any coin. In that case sum would be 0. Okay, so you'll be storing true for it. So you have stored the base condition for any sum, zero coins and any sum, and any coins then zero sum. Okay, now you operate on the other stuff. What is the other stuff? So starting from I equal to, like, number of coins from 1 to n, and sum from 1 to n. Okay, now let us assume you're starting with sum equal to 1. Okay, let us assume you're starting with sum equal to 1. Now if you are looking out to make a sum 1, okay, now we are looking out to make sum 1. Let us even just consider this example itself. Initially you have sum to be 1, okay, sum to be 1, and you're standing on this particular 5. So you see that 5 is actually greater than 1, right? 5 is actually greater than 1. Your target or your sum that you need to make is 1, but the coin that you have is 5. Can you make it? No, you need not include it. That is what one thing, you need not include it. But you'll ask to your previous thing, okay, previous side, like to your left side, you'll be asking that, is that possible for you people to make a sum of 1? Because if I need not include myself, that is for sure. 5 will be telling that I'll not be including myself, that is for sure. But can you people make the sum of 1? So it will be asking to its left, and to the left of 5 there's no one. So initially we have what do we have here? We have false, because with zero number of coins, any sum, what is the sum that we are looking out for? 1. So 1, zero number of coins and 1. Okay, what did we store here? False. Okay, we stored false here, right? So they'll be saying, no, we cannot make, because we do not have any coin, but you're asking us to make a sum of 1. Is that possible? No, it's not possible. So we have false here. So 5 will be saying, okay, then I'll also put false in myself, because I'm not including myself. 5 will be telling I'll not be including myself. 2 index is there on me, I'll not be including myself. Let us assume now we are dealing with the sum of now come here. Okay, now come here, or let us assume your sum 1 is done. Okay, sum 1 is done, 2 will also be same thing, 2 3 will be also same thing, 4 will also be same thing, 5. Now let us come to sum equal to 5. Now 5 will tell, now if you come to 5, you see that sum is actually greater than or equal to 5. Okay, sum is equal to the coin that we have, 5 here. So now 5 has two choices, either include itself or do not include. So if it include itself, what will be the sum remaining? 0, because it's including itself. So what is still left? 0. Now it will be asking to its left. Okay, to the left it will be asking, can you make a people are you people able to make a sum of 0? Then it will come to this condition where 0 number of coins and 0 sum. Yes, it is possible, because you can see here from this particular thing, 0 number of coins from 0 to n and 0 sum. Yes, it is true, right? 0 number of coins, 0 sum, it's possible. So they will be telling, yes, it is possible. So okay, then if I include myself, it is coming true. What is another case? Not include myself. Then again it will be asking to the left side, can you people make a sum of 5? I will not include myself, so still the sum is remaining the same. So can you people make a sum of 5? So it will be asking to its left. In the left, they'll be coming to this particular condition again, 0 and 5. So is that possible? No, it is false, because 0 number of coins getting a sum of 5, it's not possible. So it will be returning false in that case. So I hope you people have understood. So for each and every coin, we have two choices. Like if the sum is actually greater than that particular coin, sum is greater than particular coin, then we have two choices, include or do not include. If it is not, okay, so I'll just write those things. If your sum is greater than coin I, okay, coin I value, then two choices, one include include, or second not include, not include. And what if your sum is less than coin A? Sum is less than coin A. Then just ask your previous value, previous results. Just ask them if they were able to make the particular sum. Then just keep yourself also the same result, because you can never include that particular coin A. So you can just ask your previous one and put it in your particular coins of I. Why are we doing this? Because I does not denote, okay, coins or DP of I does not denote you'll be using all the coins till index I. It's just that you can use some number of coins till index I. That's the only thing. So remember that particular DP state. Okay, so the same thing we have coded. So first one into total, that is the sum, total maximum possible sum that we have stored in total, and then we have taken a 2D vector, that is possibility, and this particular n plus 1 denotes the number of coins, and this particular denotes the sum. Okay, so for int number of coins to be 0, number of coins less than or equal to n, number of coins plus possibility of number of coins of 0 equal to true, because whatever the number of coins it is, 0 sum is always possible, so we have mentioned it as true. And what is the second one? So this is zero sum case. Okay, zero sum case. And here zero coin case, whatever the sum it is, zero coin case, whatever the sum it is apart from zero, because with zero number of coins you can make zero sum, but sum 1 2 to what till total you cannot make with zero coins. So that's the reason we have put false here. Okay, from starting from sum equal to 1. Make a clear note of all these things. Okay, and now coming to the second thing, if for in number of coins equal to 1, number of coins less than or equal to n, number of coins plus sum to be 1, sum less than or equal to total, sum plus, if your sum is actually less than coins of number of coins minus 5, this actually going to that particular index. Okay, because we are working on number of coins, so number of coins in the sense in the array perspective it starts from 0th array, right? 0th index. So that's the reason if you're considering number of coin to be 1, that means you're working on 0th index. So number of coins minus 1 is what you're doing, so to handle that particular index. So possibility of that depends upon the previous possibility, because your sum is actually target is less than your present denomination. If your sum is actually greater than or equal to coins of number of coins minus 1, then you can include it. So including case is this possibility of number of coins minus 1, and you'll be asking to your previous people, are they able to make a sum minus coins of number of coins minus 1? Okay, you are including yourself, so your particular target or sum will be decreased by coins of number of coins minus 1. If you are not including yourself, okay, if you are not including, this is the case, you'll just ask your previous people, are you able to make this this whole sum or not? Okay, so these are the two cases, and you'll be mentioning or any of these. If it's true, then it is true. And now finally for int sum equal to 1, sum less than or equal to total, sum plus, you will be looking out for that sum that is exactly divisible by 20 or 24 or equal to 2024. And if in case the sum is actually divisible by 20 or 24 or 2024, and also the possibility is true, then we can return true, or else we can return false. Okay, there might be various possibilities of sum in the total sums, right? In the total, so now we'll be checking for each and every sum starting from 1 till the total. So if your sum is actually 1, is there a possibility of framing 1 or not? No. And also we need only that sum that is divisible by 20. So let us assume you are taking a sum of 20. So this particular first thing will be true. And now you need to check whether you are able to frame a sum of 20 or not. If yes, then you'll be returning true. Else you'll be returning false. Now you'll be even checking 24, and you will be again checking 40, 48. Or like that, all multiples of 20, 24 you'll be checking, and equal, lastly you will check if your sum is equal to 20, 24. Okay. So these are all the things that you'll check and return true accordingly. I hope you people have understood what are we doing. This very easiest approach, just that you need to use some common sense to solve this particular question, right? So I hope this made complete sense. I've explained everything from the bottom line, from the grassroots levels. There mustn't be no doubt. If in case there is any doubt, please feel free to comment in the comment section. I'll revert back to you with a good example, good explanation, right? So, and also for your information, I've created a WhatsApp channel. That description is in the group. Sorry, the group link is in the description. That channel is basically for off-campus opportunities, internships and placements, DSS, EP tricks, and everything, whatever it helps you in interview preparation and all. So all those things I'm posting there. Please join that if you're like interested in all these things, right? So that's it guys for today's video, and let us meet in tomorrow's video. If tomorrow's question is a medium or hard, in case if it's a easy question, then definitely I'll not be putting the video solution to it. And advance happy new year. So that's it from my side today. Thank you for watching. Stay tuned.